Hello, I'm David from Responsive Engineering. Today we're going to talk about contamination in common rail diesel. Firstly, a small explanation of the operation of common rail. Using this diagram, we have a supply pump here which draws fuel from the fuel tank. This supply pump pressurizes the fuel, comes up to what we call the common rail. Called common rail because it's common with all injectors. This high pressure fuel is then supplied to the injectors. The injectors are operated electronically with pulsing. It's a very high pressure system. It operates around 180 MPa or 30,000 pound in the old language. Makes for a vehicle with high performance, exceptional fuel economy, unless we get water in it. Water in common rail is very destructive. Damages the components, firstly our supply pump, the lines connecting to the rail itself, and ultimately the injectors. This is very expensive, given that a repair on a four-cylinder motor vehicle can cost somewhere in the vicinity of $9,000. A V6 or V8 somewhere around $15,000. It's quite an expensive occurrence. Water is the most common contaminant in common rail systems. And how do we get this water in the fuel system? It can come in through a fill and come in through river crossings via the tank breathers, which we'll speak about later. Water coming in through a fuel fill can be caused by water in the bottom of our Bowser storage tanks. This is quite common in the city, is that these Bowser tanks are filled up almost daily now. Now, what does water do to the common rail components? Predominantly because of our high pressure and our high temperatures, rust is very prevalent. It damages the supply pump, rusting components, seizing valves. It causes rust in lines. The rail is susceptible to rust and ultimately seizes the injectors due to rust and also from the water expansion in the tip of the nozzle. No vehicle is less susceptible. Most common rail vehicles are quite susceptible to water damage. How do we stop our vehicle getting water in the fuel system? We have really high flow rates. Common rail draws from the tank and returns in the vicinity of 40, 50 litres an hour, and another 8, 9 litres which is used. So we have a flow rate of 50, 60 litres an hour through the system. 80% of this is going back for cooling and lubrication of the components. So when we get water in it, it quite rapidly is carried through the system. The other misconception is that a filter will stop water. Predominantly, a filter is not designed to stop water. It's designed to control particulates. And for the purpose of that exercise, we've got here a 0.2 of a micron filter. 0.2 gives us basically 1/10 the size of the factory filter. And we'll demonstrate that water can easily pass through that filter with very little effort. So as you can see, that a filter in a motor vehicle will definitely pass water. It's not going to be a barrier, water entering the system. A filter is not made to stop water, given that water is a liquid. In fact, water goes through a filter slightly easier than diesel. The only true way to remove water from diesel fuel is with a high-quality water separator, such as WaterWatch. WaterWatch can separate the water from fuel. It can do this at 50 to 60 litres an hour flow rate. Coupled with that, we have a very high accuracy detection system, so that once the unit has separated water from the diesel and we see around 5 to 7 mils in the bottom, WaterWatch will detect this and send off the alarms. WaterWatch can be fitted to any diesel vehicle. It's a unique design, has won quite a number of awards. WaterWatch has a lifetime warranty. We're 100% confident in the design and the components. WaterWatch is assembled in Australia, and each unit is individually tested before being sent out. To learn more about WaterWatch, you can go to our website, which is www.responsiveengineering.com.au, and any questions, we'd love to hear from you.